जी धन्यवाद रैनिक. We are shifting focus now to new discoveries. Scientists have discovered that the area around the moon's south pole region is much more electrically alive than we thought. Data from India's Chandrayaan-3 mission from its lander Vikram actually show that just above the surface, the plasma, a mix of charged particles, is far denser and more energetic than earlier remote observations. Plasma is often described as the fourth state of matter, a blend of charged particles such as ions and free electrons. Although it is electrically neutral overall, it behaves very differently from ordinary gas due to its strong response to electromagnetic forces. On the moon, this thin plasma layer, sometimes called as the lunar ionosphere, is shaped by a complex mix of processes. A constant flux of solar wind, streams of electrons and ions rushed out from the sun and strikes the moon's airless surface. So, let us in fact take a look at what the Chandrayaan-3 Vikram lander has in fact discovered. So, this is very important to understand what the discovery is, and we will bring that to you because ISRO actually announced it with pictures, and it showed what the details of this entire discovery is. So, this is a major breakthrough for Chandrayaan-3. Chandrayaan-3 detects active plasma on the moon. What do you mean by active plasma? That it is much more electronically active than what we had earlier thought so from remote observations. Remember, Chandrayaan-3 actually landed on the south pole of the moon for the first time. Now, Rambha LP is the instrument which actually detects 380 to 600 electrons per cubic centimeter. So, this is the intensity with which they have detected the neutrons and electrons over there on the surface. Now, the plasma that has been detected near Shiv Shakti point revealing active lunar plasma environment. So, Shiv Shakti point is the place where Chandrayaan-3 actually landed, and over there only they found this electronically charged environment plasma. Now, measurements actually exceed prior satellite based estimates from electromagnetic signals. So, earlier like I mentioned, we have been having remote observations, but this the level of activity is much more when we have the ground in situ observations. Now, these electromagnetic signals highlight dense near surface activity. So, another discovery is that this is very dense than as compared to the other theories that we had in place. Active plasma actually informs designs for landers, rovers, suits, etc. to mitigate static discharge. So, this will actually help for further when you are sending in more rovers to the moon's surface. This discovery will actually help in planning how to go about the plasma over there. Now, active plasma aids lunar base planning, mining, navigation and survival. So, you have to understand that this will also aid in lunar base planning and mining and navigation going forward. So, we also know that NASA might just send in 2 more rovers over there to study the active plasma, and now Chandrayaan-3 has come out with this discovery. Joining us on the broadcast is Manish Purohit, former ISRO scientist, to take this discussion forward. Thank you so much, Mr. Purohit, for joining us on the broadcast. A very good afternoon to you, and some very big news for India's scientific field, because Chandrayaan-3 has discovered that the plasma at the moon's south polar surface is highly active, is more dense. And what more could you tell us about this discovery and how important this is, sir?
Yeah, actually this is pretty important because southern polar region of the moon is the place where most of the future missions are planned to land. Chandrayaan-4, Chandrayaan-5, LUPEX mission with the Japan Space Agency, Artemis people are planning to go to the southern polar region of the moon because we are expecting huge resources there for in situ utilization. Now, there are a few things that I want to point out here. The very first thing is the in situ experiment that we have done. Mostly when we study about the moon, when we talk about the plasma behavior, talk about the plasma nature of the ionosphere of the moon, the study is being done from the payloads or the experimental setups that are in the orbit going around the moon. This is first time ever. This is the ground truth. That's what ISRO has used the word. This is the ground truth of the lunar ionosphere. Now let's understand what ionosphere means. So when we talk about these sun's rays, the solar radiation that comes, that hits earth also and that hits moon also. But we have a protective layer. Our magnetic field lets our atmosphere stay, and those highly charged particles, we have our own ionosphere, but then that is way above the ground, hundreds of kilometers above the ground. But in case of moon, that ionosphere lies very close to the ground of the moon. Now, what are the challenges in such a scenario? When you have such high energy particles lying very close to the ground, then the communication gets disturbed. There is a constant noise of these charged particles that can hamper the proper communication. Now, previously estimates were like 5 to 50 electrons per centimeter cube, but right now the study shows that it is way beyond that. It is 350 to 500 electrons per centimeter cube, means it is multifold than what expected previously. Means when you are designing your electronics, when you are designing your payloads, when you are planning your mission, whether you are landing your astronaut, whether you are planning a probe or you are designing a rover for this particular environment, now you have to change your approach, because previously you were designing for a very small number, but right now the reality is, the ground truth is, that number is way bigger than what was expected previously. Since Artemis is planned, Chandrayaan 4 is going for the lunar sample return, there is Chandrayaan 5 with the JAXA, they are naming it as LUPEX mission, Chandrayaan 5, our Vikram lander is there, that is carry the rover of Japan Space Agency. So if so much missions are planned that are going to the polar region, this particular finding helps us in mitigating the harmful effects which plasma can have on the upcoming missions in terms of electronics, communication and the survival.
Absolutely. And Mr. Pirohit, when we talk about this discovery, it also goes on to show how it is actually very active and how it is responding to those various things that come into the picture. So, like the surface during the daytime, the surface actually interacts with the solar wind and it is influenced by that. And when it comes into the Earth's magnetotail, then that comes into the picture. So, how does this discovery actually help in that, sir?
Yeah, actually, if you look at the plasma, so plasma is a soup of high energy charged particles. And why we are getting such charged particles very close to the surface of the moon? Because moon doesn't have a protective layer. Moon effectively doesn't have atmosphere, means any high energy cosmic radiation, any high energy particle coming from the sun, the ultraviolet radiations from the sun, they can directly hit very close to the moon. Effectively speaking, they can hit the surface of the moon. When that is happening, so the study says that it is very active. Why it is very active? Because whenever there is a solar activity, that solar activity will directly impact the plasma count or the density of the plasma. The spike is observed there in the plasma activity, because when high energy radiations and particles are coming from the cosmic background, they directly impact that particular layer which is very close to the lunar surface. That is one thing. When you talk about the magnetotail, because these are charged particles and magnetic field interact with the charged particle, so whenever we are moving towards the magnetotail, there is a kind of an activity that is observed. So actually this opens up a very new paradigm, a clear picture of how the charged particles they are spread around on the lunar surface. Again, I am saying the same thing. Understanding this helps us in a big deal when we are planning our future missions, because previously the missions were designed for a count that was around 10x smaller than what right now the present situation is. Means electronics were more vulnerable, communication systems were more vulnerable, because we were not planning for such higher count. But right now we know the reality that the count is high, it is fluctuating, it is responding to the solar activities, means we should have better mitigating measures and steps to be taken in the future missions.
Absolutely. And sir, before I let you go, when we talk of the bigger picture, you also spoke about NASA's Artemis 4 mission that is upcoming right now. It will have two specific rovers, one specifically to study plasma, sir. And now with this discovery, India was the first to go to the South Pole, land over there, and now it has come out with this discovery. How will this affect future global space exploration as well, sir?
See, actually, it's a really big step forward when we talk about understanding the moon, because we are planning to go to the moon more frequently now. As there are so many missions planned in the future which are aiming for the moon. Previously, when during the Cold War era, when US and Soviets were going to the moon, they were racing towards the moon. That time they were aiming for the equatorial part of the moon. But right now, when we talk about the resource utilization, resource mining on the moon, using the moon's resources for betterment of humanity, generating power, and using that as a platform for the deeper space missions, means there will be a constant presence of humanity on the moon. There will be more frequent traveling to the moon. In that scenario, understanding each and every aspect of the moon is very important. This is one of the many aspects that right now have been revealed by the Ramba. That is a great work done by Chandrayaan 3, amazing stuff done by the research community. That is really beautiful, because this lets us understand what are the challenges. The previous picture was presenting the value that was very small. Sometimes what happens when your data is not perfect, then you design a mission, and then you find something is not working perfectly. When the mission is going on, then you realize, oh, there was some error in the data. But when we have such crystal clear data, such crystal clear experimental values, then mission planning becomes much more easier and much more robust, and that's what we need for our future missions.
Absolutely. Thank you so much, Mr. Purohit, for joining us and providing us with those valuable insights into the subject.